All right, so we're going to graph and solve quadratic inequalities, which means anytime you see graphing inequalities, that means we're going to be graphing and shading, but also solving them, so stay tuned. Here's how we're going to graph a quadratic inequality in two variables. First of all, we're going to graph the equation, act like it's an equal sign, and do what we've always done. Make it dashed if it's greater than or less than, solid if it has equals with it. Test a point inside the parabola. Usually 0, 0 if we can. And if it works, you shade inside. If it does not work or is not true, it's not a solution, shade outside the parabola, so inside or outside. Okay, let's try one here. It says graph this one, which I've already done to save a little bit of time. What I did two things. I factored it. I put it in intercept form. So I found the x-intercepts are -4 and 1. Put those 2 points in the graph here. I'm darkening them here and here. The vertex has to be exactly between those two because it's symmetric. So halfway between was -1.5, which is here. So I plugged in this point right here, -1.5 in for my x's. Got -25/4, which is 6 and 1/4, so I went down to there. I drew a dashed line because it was greater than. It did not have an equal to, so it was broken. So I'm going to plug in 0, 0. Now let's see if it works. If I plug in 0 for y, that's side 0. If I plug in 0 for the x's, I get 0 plus 0, -4. So I get 0 is greater than -4. Ask yourself, is that true? Yourself should say, yes, it is. So you're going to shade where 0, 0 is, which is inside. So I'm shading inside the parabola. That's all there is to it. Okay, a system. You have more than one. This first one, it was easy to graph because all I did, the y-intercept you can tell is 4. So I went to 4. It's a basic parabola that's going to go down. It's been shifted up 4. So I went up 4, crosses the x-axis at 2 and -2. So I plotted those points. That's the blue one that you see on the graph. The red one is this one, and I did the same thing I did on the last slide. I factored it to get the x-intercepts, which were 3 and -1. The vertex was halfway between, which is 1. Go down, we'll plug the 1 in, I got -4. Now I got to shade both of them. So the first one, if I plug in 0, 0, I would get 0 is less than 4. That's true. So I would shade inside the blue, which I'm doing right now. And the second one, I would also plug in 0, 0, and I'd get 0 is greater than -3. That's also true, so I'm going to shade inside that one too. So the answer to the system, where I would shade twice, is in between these two parabolas in this section right there. Make sure you notice that one of them is broken and one is solid. All right, this one says solve it by graphing. So this one, the graph, just watch what I do here. What I did, I went ahead and found my x-intercepts because the x-intercepts are solutions and it's asking you to solve. This one would not factor, so I did quadratic formula all through here. And I went ahead and worked out to get a couple of decimals just so I know where to put my points on my graph. So one of them was -1.69, which I'm saying is right there. The other was 1.1 now, which I'm saying is right there. Now here's the deal. I know it goes up because it's a positive x squared. I don't really care about what the vertex is. I know it's doing this. That's really all that matters. I need to plug in 0, 0 to see where I would shade. If I plugged in 0 on the left-hand side, I would get 0 plus 0 minus 4 is greater than or equal to 0. Is -4 greater than or equal to 0? No, it's not. So I shade outside. Really, all I care about is the x-axis shading because it said to solve. Remember, x-intercepts are your answer. So where would my shading cross the x-axis? Well, it would cross the x-axis everywhere that is less than or equal to -1.69. That's not very good. Try it again. -1.69, or also x is greater than or equal to 1.19. That's where I would have shaded. Greater than end up being an or. All right, this one says solve algebraically. So what I did on this one, just to save some time, I went ahead and moved the 15 over like that and factored it. When I factored it, it gave me x minus 5, x plus 3, which means my zeros or my x-intercepts to be a +5 there and -3 there. Now, instead of drawing a whole graph, I just went ahead and drew a little number line and put a 5 and a -3 on it. So I'm going to put a point, a circle, an empty circle on both of them because there's no equals. And what I'm going to do is I'm going to plug in a point over here, plug in one in between, and plug in one over here, and see what I get. And all I care about is if it's positive or negative. So if I plug in, let's say, I don't know, -4. If I plug in -4, that parentheses is going to be -9. That's going to be -1. Negative 9 times negative 1 is a positive number, so that means everywhere less than negative 3 is going to be positive. Now I'm going to plug in the 0 right here. If I plug in 0, that'd be a negative 5, that'd be a positive 3, that's negative 15. So everything in between the 3 and the 5 is going to be a minus. And then I'm going to plug in something over here. Let's say I plug in 10. 10 minus 5 is 5. 10 plus 3 is 13. 5 times 13, I don't know what it is, but it's positive, so it's positive. Now, here's all you do. I'm looking for where this inequality is greater than 0, which means greater than 0 means positive. So where is it positive? It was positive less than the negative 3 over here, and also over here greater than the 5. And that's all you do on that one. That's solving algebraically. Didn't have to draw the whole graph. Just find your zeros, draw the number line, and test the points. Now, I'm going to tell you something I shouldn't tell you. This is going to be a secret. The signs are going to alternate like every time. So if you just plug in one number, you can just fill out your whole number line. I didn't really say that though, so you didn't hear me. All right, one more problem here. This one says the number T of teams that have participated in a robot building competition for high school students can be modeled with this equation, and they're going to give you the equation, and it says the equation is only good for x is 0 to 9, where x is the number of years since 1992. For what years was the number of teams greater than 100? So this is the number of teams over here, hence the T. So what I'm going to do, it says greater than 100. So I'm going to set up an inequality and set that greater than 100, which I did right there. Then I'm going to move the 100 to the other side, so I have a 0. So it gives me this. That's not going to factor, obviously. It's going to be hard to graph. So what I'm going to do is I'm going to use my calculator to get my parabola. And that's what I did right here. And that's a picture of my calculator. Now, obviously that's a parabola. It's crossing the x-axis right there, which is about, a little bit more than 4. What it tells you down here, you can actually punch that in your calculator, 4.23. So for what year was the number of years was the teams greater than that? Every year past 4.23, or a little over 4 years, 4 years, 3 months, something like that. They would all be greater than 100. So we can use technology too occasionally to find out what our answer is, and I'll show you that tomorrow too. A lot of things I want to show you here on this lesson that I can show you in class tomorrow. Really wanted you to get the basics today off this video. Watch parts of it again if you need to, because it will help you to have a good head start tomorrow. So I'll see you then.